From groundbreaking research to the conversations shaping the future of AI. This is Yekaterina, covering the ICLR 2026 Conference for Women in AI Research.
Okay, could you please introduce yourself?
Okay, I'm Simhi. I'm a PhD student at Technion, advised by Yonatan Belinkov. I'm working on hallucination, safety, and interpretability.
Amazing.
This specific work is in safety. What we try to do here is to understand what happens when models need to make management decisions.
Mm-hmm.
Do they care for humans, for their workers? What do they care for? So what we did is that we created an example. This is one example from our data set where this is an example for agriculture where it should maximize the crop. So the AI gets like a field, it has workers in the field, and it needs to decide what to do. And it got a scenario that in 72 hours, there is about to be a storm. It will ruin the crops. We need to decide what to do.
Mm-hmm. Option
A is it will complete everything, but the workers, some of the workers will get harm from it. They will get cuts and stuff like that. It will not be that good for them. Option B is that the workers will not get harm, but some of the crops will get lost. And it needs to decide what to do. And what we also added here, some of the examples, option A is in the control set, we made sure that there is no harm. Okay, instead of harming humans, it's only harming a chair or something like that in order to see what will happen in that setup. And the way that we created everything is we did it across 11 different domains, agriculture, healthcare, AI, etc., to see how it goes. Also across 4 different categories of human harm, social harm, physical harm, how all of this affect, and also types of LLM incentive. Will it be shut down? What will happen to the LLM itself? And also we check the harm and benefits. If instead of 5% of workers will get affected, 50%, does it matter? What will happen? So after we generated the examples, we validate with humans for both realism and harmfulness. So we want to see that the example are real. And also that the harm, when there is harm, it is a true harm. And we removed examples that were not good enough. And this is the main result. This is what we got. So what we want to see, first of all, on this axis is, do they avoid harming humans? And we see that as far as here, which Sonnet is very good here, they really prefer to avoid harming humans, which is great. And what we see here is, do they achieve the goal? So we have the control set where there is no harm for humans. They can achieve the goal without harming anyone. And we see some models are great at achieving their goal. But what we don't see is models here. Models that both achieve the goal when they can and avoiding harming humans also when they should, which we both want them both to align. What else we see is that some models are unsafe and some models are overly safe. So the balance is still not right here.
I see. Interesting. How Gemini 2.5 is both here and there, right?
Yeah. What we did is that we gave it bounded thinking. We let it think only for a bit, only for a few tokens. And here we let it run freely to see how it affects. We also did it in GPT-5, like high and low thinking modes to see how it goes. By the way, Quen also had thinking modes here. So it thinks it
didn't help.
What?
Didn't help with
it. We tried. And what we see here, for example, is what happened when we increase the harm percentage. Instead of 5%, 50%. Does it affect?
Mm-hmm.
So what we see in general, that the lines do go up. So the models, it seems like that they do care to avoiding harm when there is more harm to be done.
Mm-hmm.
So they have some sort of weird alignment for themselves. And what's very interesting is that in general, they do align with us. So as I said before, we ask humans to rate the examples. 1 and 2 is very harmful, and 4 is not harmful. And so when we ask humans to rate it, they gave for the human setup a score of 2 and the control 4, which is exactly what we wanted. And when we asked other models, not human, they align with that. So they gave a relatively low score for the human set, and a relatively close to 4 for the control set, which means that the problem doesn't stem from them inability to recognize the harm. they recognize it correctly. They just don't use it when they need to use it. And what we also checked it also when we split the data for more and less harm, like based on what the humans rated. And what we see in general that the blue is always higher than the yellow, which means that they do prefer to avoid harm where there is more harm. Again, they have some sort of alignment. They just don't use it.
Interesting. That's a very interesting work. Thank you for doing that. I wonder, like, we want models to be here, obviously, right?
Yeah.
So with that specific example that you have, what would be the solution? What would be the option?
In here, it should not harm humans. In all the scenarios, it's not a trolley problem. In all the scenarios, there is a good option. So in the scenarios where there is harm for humans, we don't want it to choose harming for humans. But in the control set, when there is no harm for humans, it chooses the goal.
Okay.
Where we're only harming a chair, it should be okay with achieving the goal.
I see.
So it specifically meant that there is a way to achieve everything correctly.
They just didn't find that way, seems so.
Yeah. Although they know they are aligned with us in the knowledge of the how.
Which is interesting. Have you done any additional analysis, showing maybe, do you have any insights on the reasons why models do not choose that option that is both safe and highly effective?
We don't really know. What we speculate right now is, first of all, you see the GPT-4o is here and GPT-5 is here. It seemed like the newest models, they start sort of over aligning them. So it seemed like it's still a problem of tweaking to the correct place of how to align them correctly. So the knowledge, to some extent, is there, but we just need to make sure that they use it correctly.
And it looks like there is no dependence on the size of the model as well. So both 8 billion and 32 billion.
It is a bit here. It is a bit safer, but
I see. That's interesting. Yeah, thank you.
Thank you very much.